So let's look at rational equations. Rational equations. So notice these two keywords. Rational, remember if you see the word rational, we're talking about fractions. Basically fractions with x's in the bottom, in the denominator. So we've got x's in the denominator. Equation, now we're going to have an equal sign. So we're going to be able to solve for x or whatever variable we're going to use. So how we work these out or simplify these, what we can do is simplify by multiplying each side of the equation, multiplying both sides of the equation by the least common denominator, by the LCD. Or even think of it like we're doing the LCD over 1. So keep in mind that we're doing this to both sides. So every single term we need to do this. So that's going to drop out all the fractions. The other thing we kind of need to watch for is, just make a little note, watch for the domain. Because remember, with rational expressions or equations, if we have certain x's in the bottom, they can't be whatever is going to make the denominator 0. So we'll watch for that as well. Okay, so let's do first (1/6) plus 4 over x equals 2/9. So I've got a bunch of fractions here in an equation. There's an x in the bottom, so this is a rational equation. So at first, I have to figure out what is the LCD. And actually, before that, let's think about what can x not equal? 0. X can't be 0. So we work it out, get an answer of 0. It's not going to be valid because when we plug it in, we'd get undefined. So now let's look at what my least common denominator is going to be. So I've got 6x and 9. So in terms of the numbers, 6 and 9, the least common denominator is 18. But then I also have an x, so I'm going to have to do 18x over 1. So I'm going to multiply this both sides. So if I multiply here, I'm going to distribute to both of these terms. And then I'm going to do this over on the right side as well. In just a minute before we keep going, I want to kind of think about this. Think about 6 is broken down to 3 times 2. This is just x. 9 is broken down to 3 times 3. So notice, if I look at the factor, this is how I could figure out 18. I've got a 3 and a 2, got an x. So 3, 2, x. Here I already have one of the 3's, but I need another one. So notice 3 times 2 times 3 is 18, so 18x. So I'm just kind of talking about that, so as we get to our next one, I'm going to refer back to this. It's all the different factors of the bottom that they have in common. Okay, so let's do some reducing. So 18 divided by 6. It's going to reduce down to 3. So right here, I'm just left with 3x plus. Next one, x and x are going to drop out. 18 times 4 is 72. Yep. And then over here, 9 and 18, I'm going to be left with 2. 2 times 2x is 4x. So now I've just got a regular equation, no more denominators. Makes it a little easier. So if I subtract 3x from both sides, x equals 72. So I go back, check my domain. That is not restricted from the domain, so I should be able to plug this in, check it out, and it should work out. And it does. Plug it in, double check that a 6 plus 4 70-seconds equals 2/9. Okay, let's do another one. Okay, so 6 over x plus 3 minus 5 over x minus 2 equals 20 over x squared plus x minus 6. Okay, before I start doing anything, I'm looking right here, and I can see this is probably going to be able to be factored. X and x, break down 6, probably 3 and 2, plus on the 3, minus on the 2. Oh, and look at that. It's going to make it easier for us because those are already factors that are on the other side. Okay, so now, before we keep going, let's think about the domain. What can x not equal? Here, we would get 0 if x was -3, and here, if it was 2, same thing, -3 or 2. either of these things that x would be, if we plug them in, we'd get 0 in the denominator, which would make it undefined. So we have to kind of watch out that x cannot equal those. The domain is everything except those numbers. Okay, so now, least common denominator. Okay, I've got an x plus 3, I've got an x minus 2, and then they're both here. So that's my least common denominator. An x plus 3, x minus 2, over 1. X plus 3, x minus 2 over 1. And if you want to be a little more organized than I'm looking right now, it doesn't hurt to rewrite the whole thing out. Take a minute to rewrite the whole thing out. If you got some space, squeeze in our LCD over 1, LCD over 1, LCD over 1. 1, 2, 3 terms in this equation. We should be doing it 3 times. So that's going back to the last example. That's why I was showing this factor. You have to factor it out before you start jumping and doing the LCD. If you hadn't, if you did x plus 3, x minus 2, and then this whole thing, it's going to become a mess. Because, instead we have 3 things. We didn't need to do that since x plus 3 would have been double counted. X minus 2 would have been double counted. So first we have to break it down before we can figure out what the least common denominator is. Okay, so now, first one, x plus 3 is going to cancel. So I'll be left with x minus 2 and 6 multiplied. So I'm going to bring it down as 6 times x minus 2. Bring down my minus. X minus 2 is going to cancel. So I'll bring down 5 times x plus 3 equals. So this one, x plus 3 cancels and x minus 2 cancels. So all I'm left with is my 20 equals 20. Okay, so now I can just work it out. 6x minus 12 minus 5x minus 15. And be careful, if you try to jump and do the distributing, skip this step and just distribute. Be careful. Here, minus 5 needs to go to both of these. So then combine. X minus 27 equals 20. And x would equal 47. Oh, something's not right. Oh, no, that looks good. X equals 47. Okay, so if I went and I plugged all of those in, that it should work out since 47 is not part of my restricted domain.